Let's look at voltage. Now, you've already heard of voltage and you've in fact used it as part of your circuit analysis. And it was a very useful concept in those situations. And along the way, you may have even heard people using the terms electric potential or potential difference in place of voltage. So, how do all these terms relate? And do they relate to electric potential energy? Seems like they should. So, before we start, I've got to be honest, the terminology is a tad confusing here. So, to minimize confusion, let's relate to our formula sheet. And you'll note that voltage, also known as electrical potential, or also known as potential difference, is shown as a capital V, not a little v like velocity. And we can add a delta in front of that capital V, and delta V is our change in voltage. And electrical potential energy on the formula sheet is shown the same way as our previous potential energy, a capital E with a subscript P, not to be confused with our capital E, which is electric field strength, as you've already played with. So always check for the little subscript P to be sure to clarify, is it electrical field strength or is it electrical potential energy? So let's look at the units for each of these. Well, voltage is in volts, and that's easy to remember, which is the same thing as joules per coulomb. Electrical potential energy, as we know, is in joules, like all energy. Electrical potential energy is calculated as FED, the electrostatic force times the displacement of that charged object. Or it could be shown as KQ1 Q2 over R, as you've already worked with. The change in voltage, or delta V, is the change in electric potential energy of an object divided by Q, that is the charge of that same object. Or we can show voltage as KQ over R. So basically, electrical potential energy and voltage are both useful and very similar. Both relate to moving charged objects in an electric field and or close to other charged objects. They both depend on position or change in position of an object. Also, both are understood to be relative to some reference. The difference is that electrical potential energy depends on the charge of the object itself, while voltage does not. It's also worth noting that both of these are scalar quantities, not vectors. They may have negatives, for example, minus 100 joules or negative 12 volts, but these negatives have nothing to do with direction. And remember, vectors have both magnitude and direction. The negatives in these scalar quantities simply indicate a loss or a decrease in energy or voltage.